Hello and welcome to Out to Lunch. Here we are at the season finale. We're very excited to be demoing some of the activities at the teacher workshop this summer. This is Margaret Mooney, and this program is presented by ESIP Education. And we're going to start today with Becky Reid coming to us from California. And we are promoting the teacher workshop, which is computing in the classroom, coding, gadgets, and STEM. And Becky is going to start with block coding. Thanks, Becky, for presenting.
Hey, you're welcome. I'm happy to be here. So I am Becky Reid, and I've been ESIP Education for quite a few years now and started to do some coding with students in the classroom. I have been using Scratch primarily, and that's a block coding language. It's similar to code.org, and there's some other block coding languages, and that's just an easy entry point for students to be able to start thinking like a computer programmer without having to type all the codes in. So it's a fun entry point. And I'm just going to show you a little bit about what Scratch can do, and then kind of transition to what Kalo's going to talk about, which is doing some programming with actual little machines and bots that can run around. So I have my Scratch home open because I'm a teacher. I have my teacher account. So I'm going to show you what it looks like if you just went to Scratch. And actually, I'm going to give you, okay, I just put in the chat box some of these links that I'm going to be using. All right, so you should be able to see now what would look like, what Scratch would look like if you just showed up. And you can go to the Create section and just start playing with Scratch if you want to. You can join Scratch, and you can join Scratch as just a regular person, not as an educator. I'll show you how to sign in as an educator in a minute. Or if you already have an account, you can go ahead and sign in. When you go in and you hit the Create button that I showed you, you're going to get a screen that's just a tutorial, so you can play around with some of these things. This little cat guy here is called a sprite, and that's just the object that you're going to be able to move around. I'd suggest if you were coming in and wanted to just start playing around with Scratch, you know, go in, you don't even have to create an account, and just start looking at some of these tutorials. They're very simple and easy to work with. So that would be exploring Scratch. You want to go any farther than this, I recommend a teacher account, especially if you want to start using this with students. And the advantages of a teacher account are that you can create student accounts, one per student, and it doesn't ask for the student's individual email. You can reset the password of your students, so when they say they forgot their password, you're not helpless. And the students can still share with the whole world, but the teacher can see all of the comments and anything that's going on with the student, so you can shut down or report any inappropriate some things that might be there. The key element here is that you must register before, well, you don't have to register before the workshop. We can still play with you if you do not have a teacher account, but it takes 1 day. They need to verify that you're an educator. So to get a teacher account, you're going to just create a username and password. They will ask you for some information about your school, and then they'll verify that you're a teacher, and then you're good to go as a teacher account. But again, if you just want to play with Scratch and learn how to use it, you don't need to have a teacher account. And I'll show you another resource for teachers. So the last link that I did put in the chat gets you to a teacher resource page. And this is pages designed specifically for educators, but you don't have to have a teacher account to get in there. And it has some things new to Scratch, familiar and experienced. So you can start exploring Scratch at the level that you want. All right. And if you go in, you can see some of the resources. and look things up. So you could see some of the other resources based on maybe you want the grade level or the curriculum. You can also search in the search bar for a particular curriculum. Everybody here, almost everybody here is some kind of science educator and earth science educator. So there are some examples of some Scratch programs that students have written, and you can look at them. So this is just a quick look at an example of a game that students wrote. And if I was going to send a earth science student in to use Scratch, it would be more of the process of both creating and combining it with their science resources than to make a fabulous game. The games are pretty crude that they make in Scratch, but it could be fun. And finally, we have MaKeyMaKey as a Kalo is going to talk a little bit about MaKeyMaKey, but there's a whole section of MaKeyMaKey projects that are written in Scratch that you can explore and that we will do in the summer. We'll be looking at more of these once we get a little bit more familiar with block coding and Scratch. We'll be using that to do some more things with MaKeyMaKeys and Ozobots that Kalo is going to be talking about. Kalo, are you ready?
I am.
Okay, hold on. I'm going to give you the presentation. So I think you just have to click that you are accepting the presenter.
Change presenter.
I gave it to you, so you have to click accept.
I didn't see anything that said accept come across my screen this time, like last time.
Margaret, can you handle this? Because I sent it to Kalo.
Yeah, maximize maybe that. There, I got it now.
Okay.
Sorry, I had my other screen maximized, which put it behind everything. All right, so my name is Kalo Haslem. I am a STEAM teacher at Capital Encore Academy in Fayetteville, North Carolina. I've been part of ESIP for 3 years, working with the education cohort, and I'm going to be presenting a few tools that we can use in the classroom. So I'm going to be presenting with Ozobot, specifically the Ozobot bit and the MaKeyMaKey, and their application into the classroom, both as a entry-level use and kind of how it can feed into more advanced stuff. So the Ozobot is a company that makes a mini robot that in an educational and entertaining way introduces children to the world of logic, robotics, and programming, essential skills for new generations. And it can read code on digital and non-digital surfaces. It can be integrated with any subject and is only limited by the user's creativity. This applies to both teacher and the student. Activities can be as simple as a free draw, as you see on the right side of the screen. And that is one of the students from one of my first grade classes. Or it can be as complex as using variables and functions within the Ozobots online application to create programs, games, or interactive activities. So this would be an example here of the digital use. There's 3 apps that they have currently, and they all work great. They all serve different purposes. This is an example of the non-digital. So on the left, you see a sheet that has the different codes, and they would be a series of kind of colors, such as Morse. Think of like Morse code. And then that is actually a 3D printed spider that we use for a Ozo spider. And then we do linear distance, and we do angles, and that would be a 4th grade project that we do. Here's an example of an Ozo math activity where This is my second grade, and what they do is they had it run 10 times, and there's obviously 4 options. And here is a video of them kind of doing it. It traces the lines, it walks the lines, and then they kept data on that whiteboard you see at the top of the picture. And then they had to do some addition problems, such as if you were add the blue and the red, the green together, how many trowels. In older classes, you could do ratios, proportions, percents, translate that between the different things, kind of a fun way to practice their math problems. This would be an example from the Ozobots that has more of the variables and the functions in it, so it can get extremely complicated. You would then load this onto the Ozobot, and it would it's called flash code, where you put the Ozobot on the screen and then it flashes the series of code, it saves that, and then it can run that code. These can be used with different applications. There's a lot of stuff in their online library that you can use, and this is one example of it for an activity. I believe this is an area of different geometric figures. Here, one nice thing about Ozobots is that you can also preview what it would look like in JavaScript, which is often not available when you're doing block coding. So on the right-hand side, you would see the JavaScript translation of what that block code actually means when it comes to the Ozobot. Next one we're going to talk about real quickly is and introduces the MaKeyMaKey, as talked previous. The MaKeyMaKey is an invention kit for the 21st century, where you can turn everyday objects into touchpads and combine them with programs. Students, through using their imagination and understanding of electrical currents and even possibly programming, turn what could be typical activities using a computer and a keyboard or a controller into a high-level thinking, interactive, and creative projects. So you, the student, or whatever you did, you create the electrical current, just like when you hit a key on a keyboard, it touches and makes the electrical current, then sends that signal to the computer, and then the computer does whatever the action is within the coding. Top left, you see one of their very typical banana pianos. So the bananas are now the keys, and you make the electrical circuit between you and the bananas, and then it obviously plays the note that would be on the keyboard or on the screen. And then to the right, you see just a very quick animation of kind of how it works in generic terms. This is a larger-than-life Nintendo controller one of my students made. So again, it can be very basic in application, where you actually just take something and you make it. But my students had to engineer this. They had to create the pads. They had to engineer how it works with the MaKeyMaKey. They had to try it out. So there still is a level of creativity in there. I've also made a multiple choice touchpad where they can answer multiple choice questions using the touchpad as well. You can also do interactive educational maps. I have not done one of these yet. These are something that I saw at my other school. This is something I wanted to apply later, but you use kind of where the silver pot's at, that would be electric, that's probably aluminum of some kind, and that then goes to the program, most likely in Scratch or somewhere else, and then you have an interactive map because of the MaKeyMaKey. This is something me and some of my students are on, which is a data collection tool for a Hot Wheel track with timing gates. How it works is you have a piece of copper flag and it twists on this wood peg here, and when the car goes past, you'll see in a second, it'll actually hit this eye bolt, and that will send the signal to the computer, which is continue or start or stop. So you can actually collect this time data without using stopwatches. So it's a very creative way, an interactive way, a new way to use a MaKeyMaKey with Hot Wheels in order to collect data for speed, acceleration, velocity, so on and so forth. And here's a short video of kind of how it goes through. You'll see the Hot Wheel kind of run through the track and hit the gate, and that gate will actually hit the eye bolt, which is actually attached to a wire this time, and then attached to the MaKeyMaKey alligator clip. So again, as you see the car go through, it hits the gate, and the gate flies open, and then it touches the eye bolt right there, and then that's what sends the signal to the MaKeyMaKey in order to click, which is the start or stop. And so on my way out, I thought I'd show this fun video of the AHSBots and how creativity can play in. We are a STEAM school, so the arts is very important to us. And so here's a video of some characters that we made with their Ozo groove And so that would be kind of the conclusion to kind of an a preview of the Ozobots and MaKeyMaKeys for our project. And then I will turn it over to whoever is next for presenting.
That was great, Kayla.
Yeah, that was wonderful, both Becky and Kalo. It's really exciting to see the integration of the coding with the objects and the real world. I'm not sure if we have Margaret at this point.
Yes, I'm here. I spoke up. Sorry.
Margaret's ESIP Group 4.
Of course.
Can you guys not hear me?
Oh, we can hear you.
We can hear
okay,
you.
good.
Your name isn't on the thing, though.
Oh, I see. Yeah. It's because I used Dan Key's the password to start it. So, anyways, I thought both those presentations were excellent. I'm excited about the ESIP summer meeting. It's exciting that there's MaKeyMaKey demos or in Scratch already, apparently. So, thank you. Does anyone have any questions for Becky or Kalo?
No, but I'm looking forward to playing with both of you.
Yeah, and I was just thinking this interactive educational map could have both a MaKeyMaKey and Ozobot component to it.
Yeah, absolutely. I've seen plenty where they draw the black line and you kind of make what I would consider like a trail going from one point to another point. You can then code them to pause. Then you could click on them as they go past. I've been trying to think of a way to be able to do it where the Ozobot could trigger the MaKeyMaKey to send the signal, but you'd have to have a wire attached to the Ozobot. So maybe we'd have to do like a running track, kind of like you would think with like a rail system or something like that. But I haven't gotten dove that far into that yet. That might be a project for one of my students to do. Then the other part is making it so it completes that electrical circuit and that part. But yeah, there's definitely a way to do that, or where you just intertwine the two, where they go and it goes to a certain point, it pauses, you hit the button yourself, and then it reads the information, and then the Ozobot continues to the next point, so on and so forth. You could also do like using history of, let's say, battles between, for the Civil War or battles in World War II. You could do something like that. You could do discoveries, or you could do it with a star map, thinking more kind of ESIP and kind of environmental, or not environmental, yeah, environmental, but space and, that kind of stuff. So there's definitely, the application is definitely limited only by kind of how you want to think about it, how creative you want to be with it.
I was thinking it'd be interesting to do like a quest where you told some of the reasons why like a polar orbit satellite gets launched from the West Coast, because it's easier to get in an orbit that helps those satellites stay in orbit. Meanwhile, the geostationaries get launched from Cape Canaveral in southern Florida because it's easier to get above the equator. So something like that with the map.
Mm-hmm.
Some sort of quest where they had to answer questions related. Of course, I'm thinking satellites. So
right. Yeah, you could also do like possibly like where you draw like research the trajectory of satellites and rockets and how they're launched, and then the Ozobot could go through it. And kind of you could do a video where you explain why they go at that trajectory. There is one that's on their website. They have a whole bunch of different lessons that have been started to get put together by either teachers or by the Ozobots education department themselves, where it actually circles the Earth, the Earth circles the sun, the Ozobots the Earth, and it has the different codes to either speed up or slow down based off gravitational pull. So you can see how it speeds up and slows down and kind of talk that through. Another one that I was getting ready to start making is orbits of all the different planets, and if you could like use them and take them into a scaling of how far they are from each other, and watch all the Ozobots circle, and kind of then comparison based on why does this one go slower than that one, different things like that. So again, it's all about the application. There are ways to make them count, but that would be in the functions and the variables. And so they, like I said, they do have a geometric one that I've just started playing with, where you upload the code to the Ozobot. You then run the shapes, and it'll actually flash at you. And green is the 10 spot, and then blue is the 1 spot for the bit, because it doesn't talk to you. The new Evo one, it does talk to you, and it would say the number, I believe, which is why they put that function on there. So, but the bit will flash at you. So if it's, let's say, 15, it would give you 1 green and then 5 blue. So you can count those in order for it to be calculated for areas.
Sounds like the sky's the limit. Well, thank you, Kalo and Becky, for presenting today. And thank you, everyone, for tuning in to Out to Lunch.
Before you turn this off, and Margaret, if you want to stop recording, I have a question for the group here.
Okay, I'm going to stop recording.